Hello everyone. In this lecture, we shall have a keen look at relational database model in database management systems. The objectives of this lecture is to learn the relational database model, what it offers in a logical view of data. Second objective is about the relational model's basic component relations. 3, that relations are logical constructs composed of rows, tuples, and columns, which are also called as attributes. That relations are implemented as tables in a relational database management systems. The fifth objective is about relational database operators, the data dictionary, and the system catalog. The sixth objective is how data redundancy is handled in the relational database model. And the very last objective of this lecture is why indexing is important. A logical view of data, relational model. Relational model, or RM in an abbreviated manner, represents the database as a collection of relations. It views data logically rather than physically. Table, structural and data independence resembles affine conceptually. Relational database model is easier to understand than hierarchical and network models. A relation is nothing but a table of values. Every row in the table represents a collection of related data values. These rows in the table denote a real-world entity or relationship. The table name and column names are helpful to interpret the meaning of values in each row. The data are represented as a set of relations. In the relational model, data are stored as tables. However, the physical storage of data is independent of the way the data are logically organized. Tables and their characteristics. Logical view of relational database is based on relation. Relation thought of as a table. Table, two-dimensional structure composed of rows and columns. Persistent representation of logical relation. Contains group of related entities or entity set. It is built from a unique set of tables, also called relations. A table contains data about just one entity. Tables must have a primary key associated with it. Tables are linked by primary and forward keys. Other characteristics of relational database table include a table is perceived as a two-dimensional structure composed of rows and columns. Each table row, also called as tuple, represents a single entity occurrence within the entity set. Each table column represents an attribute and each column has a distinct name. Each row or column intersection represents a single data value. All values in a column must conform to the same data format. Each column has a specific range of values known as the attribute domain. The order of the rows and columns is immaterial to the database management system. Each table must have an attribute or combination of attributes that uniquely identifies each row. Relational models have keys. Each row in a table must be uniquely identifiable. A key is one or more attributes that determine other attributes. Key's role is based on determination. Example, if you know the value of attribute A, you can determine the value of attribute B. Keys also represent functional dependence. For example, attribute B is functionally dependent on A if all rows in a table that agree in value for A also agree to value for B. Composite key is composed of more than one attribute. That's the very first key. So key attribute, any attribute that is part of a key. Super key is any key that uniquely identifies each row. Candidate key, a candidate key is a super key without unnecessary attributes. Nulls. Nulls just generally represent no data entry. It may also represent no permitted, not permitted in primary key. Should be avoided in other attributes. It can also represent unknown attribute value, unknown but missing attribute value, a not applicable condition. It can create problems when functions such as count, average, and sum are used, can create logical problems when relational problems are linked. Keys continued. Controlled redundancy. It makes the relational database work. Tables within the database share common attributes, enables tables to be linked together. Multiple occurrences of values not redundant when required to make the relationship work. Redundancy exists only when there is unnecessary duplication of attribute values. Redundancy, in the database perspective, refers to the duplication of records in a table or database. With keys, redundancy is often minimized and controlled. In the slide, Vend code is the primary key in the bottom table. Have a look at the vendor table. The very first column, Vend code, is the primary key. In the product table, Vend code is also available as a very large column. And you'll see that the vendor table is linked to the product table using the same column header. Now, Vend code in table product is known as the foreign key. When a primary key of one table appears in another table, it is called as a foreign key. The same representation is given in slide number 10. Have a keen look at the illustration. The vendor table, primary key is Vend code. In the product table, the primary key is prod code and Vend code is the foreign key. Keys continued. Other types of keys include foreign key, an attribute whose values match primary key values in the related table. Referential integrity. Referential integrity is a property of data stating that all its references are valid. In the context of relational databases, it requires that if a value of one attribute of a relation references a value of another attribute, then the referenced value must exist. Foreign key contains a value that refers to an existing valid tuple or row to another relation. Secondary key, on the other hand, is an additional key or alternate key which can be used in addition to the primary key to allocate specific data. Secondary key is used strictly for data retrieval purposes. The summary of all the keys are found in this table. Students are requested to refer to this table for revision purposes as a summary of all the keys in the databases. So in total, we have 5 types of keys: super key, candidate key, primary key, secondary key, and foreign key. Integrity rules. Many relational database models enforce integrity rules automatically, separate to ensure that application design conforms to entity and referential integrity rules. Referential integrity refers to the relationship between tables. Referential integrity is a property of data stating that all its references are valid. Referential integrity refers to the accuracy and consistency of data within a relationship. Relational set operators. Relational algebra defines the theoretical way of manipulating table contents using relational operators. Use of relational algebra operators on existing relations produces new relations. Relational algebra defines the theoretical way of manipulating table contents using 8 relational operators. The operators include select, project, union, intersect, difference, join, product, and divide. The illustration in the slide represents select operator. Select operator is also known as restrict. It yields values for all rows found in a table that satisfy a given condition. Select can be used to list all of the row values, or it can yield only those row values that match a specified criterion. In other words, select yields a horizontal subset of a table. The illustration in the slide represents project operator. Project operator yields all values for selected attributes. In other words, project yields a vertical subset of a table. The illustration in the slide represents union and intersect operator. Union operator combines all rows from 2 tables excluding the duplicate rows. The tables must have the same attribute characteristics. The columns and the domains must be compatible to be used in the union. When 2 or more tables share the same number of columns, and when their corresponding columns share the same domains, they are said to be union compatible. The intersect operator yields only the rows that appears in both tables. As was true in the case of union, the tables must be union compatible to yield valid results. For example, you cannot intersect if one of the attributes is numeric and the other is character-based. The illustration shows examples of differences and product. Difference operator yields all rows in one table that are not found in the other table. That is, it subtracts one table from the other. Product operator yields all possible pairs of rows from 2 tables, also known as the Cartesian product. Therefore, if one table has 6 rows and the other table has 3 rows, the product yields a list composed of 6 by 3 that is equals to 18 rows. The data dictionary and system catalog. Data dictionary provides detailed accounting of all tables found within the user or designer created database. Contains at least all the attribute names and characteristics for each table in the system. Contains metadata, data about data. System catalog contains metadata. Detailed system data dictionary that describes all objects within the database. Let's have a look at a simple view of data dictionary and system catalog. Data dictionary provides a detailed description of all tables found within the user or designer created database. Thus, the data dictionary contains at least all of the attribute names and characteristics for each table in the system. In short, data dictionary contains metadata, that is, data about data. System catalog is like the data dictionary. It contains metadata. The system catalog can be described as a detailed data dictionary that describes all objects within the database. This may also include data about table names, the table's creator, the creation date, the number of columns in each table, the data type corresponding to each column, index file names, index creators, authorized users, and access privileges. Because the system catalog contains all required data dictionary information, the terms catalog and data dictionary are often used interchangeably. Relationships within the relational database. There are three main types of relationships formed with relational databases. These include one-to-many relationship, one-to-one, and many-to-many. Let's explore these relationships in more detail in the following set of slides. One-to-many relationship. Relational database norm found in any database environment. A one-to-many relationship is the relational database norm. To see such a relationship is modelled implemented, consider the painter paints painting. So one painter does more than one painting jobs. The relationship is one to many. One is to one. One entity related to only one other entity and vice versa. Sometimes means that entity components were not defined properly. Could indicate that two entities actually belong in the same table. Certain conditions absolutely require their use. For example, one department chair, a professor, can chair only one department, and one department can only have one department chair. Therefore, the relationship here is one-to-one relationship. One-to-many relationship. Pardon me, many-to-many relationship. A many-to-many relationship is not supported directly in a relational environment. However, many-to-many relationships can be implemented by creating a new entity in one-to-many relationships with the original entities. It is implemented by breaking it up to produce a set of one-to-many relationships. Avoid problems inherent to many-to-many relationships by creating a composite entry. A composite entry includes foreign keys, the primary keys of the table to be linked. To explore many-to-many relationship, consider a rather typical college environment in which students can take many classes, and each class can contain many students. Data redundancy revisited. Data redundancy leads to data anomalies. Those anomalies can destroy the effectiveness of the database. You also learned that the relational database makes it possible to control data redundancies by using common attributes that are shared by tables called foreign keys. The proper use of foreign keys is crucial to controlling data redundancy. Although the use of foreign keys does not totally eliminate data redundancies, because the foreign key values can be repeated many times. The proper use of foreign keys minimizes data redundancies, thus minimizing the chance that destructive data anomalies will develop. Let's see the use of foreign keys in the invoicing system. The primary key of customer table appears as a foreign key in the invoice table. The primary key of product key appears as the foreign key in the line table. Indexes. Suppose you want to locate a particular book in the library. Does it make sense to look through every book in the library until you find the one you want? Of course not. You use the library's catalog which is indexed by title, topic, and author. The index is either in a manual or in a computer system that points you out to the book's location, thereby making retrieval of the book a quick and simple matter. An index is an orderly arrangement used to logically access rows in a table. There are two types of indexes, index key and unique index. The index key, in fact, the index's reference point. More formally, an index is an ordered arrangement of keys and pointers. Each key points to the location of the data identified by the key. A unique index, as its name implies, is an index in which the index key can have only one pointer value associated with it. The pointer value is generally the row of the table. To summarize this lecture, tables are basic building blocks of a relational database. Keys are central to the use of relational tables. Keys define functional dependencies. The keys include superkey, candidate key, primary key, secondary key, and foreign key. Each table row must have a primary key that uniquely identifies all attributes. Tables are linked by common attributes. The relational model supports relational algebra functions. The operators include select, project, join, intersect, union, difference, product, divide. Good design begins by identifying entities, attributes, and relationships. The relationships include one-to-one, one-to-many, and many-to-many. So this concludes our lectures. Thank you, everyone.